What's up, everybody? My name is Napnexter. Welcome to Scratch again. So here's a little Wikipedia article about Kepler's equations, about orbital mechanics. He has several of them, like, for example, here's the equation to get convert the mean anomaly from the eccentric anomaly. To calculate that, there's this little function. And then we also got the ellipse equation right here with the eccentricity and everything. So, and then we also have, and then we'll also need to find out the orbital period, and that's actually pretty easy. So if we search orbital period like this, we have the orbital period. The equation is this: the 2 pi times the semi-major axis over the gravitational parameter, which is pretty much the mass times the gravitational constant. And the gravitational constant, it won't be necessary, but gravity will. But the mass of the actual object will. The rest of the equations are all located here, and we might not. I'm not sure if we'll encounter any more, but yeah. So we have various. So this relates various geometric properties of an orbit of a body subject to essential force and everything. So this is the article. Before reading these, I recommend you read it. Anyway, let's get to it. Let's create a new project. And let's select our backdrop. They have a backdrop of stars. So let's put that in. Okay, there's the moon. Well, I don't need the moon. Galaxy, how about that? There we go. And then let's call this sprite the sun. And this is what everything revolves around. Okay, so first let's do a private variable called mass. We could actually delete my variable. It's private called mass, and then let's set up a private called x and a private called y. And then we'll also have a forever loop. And then we'll do cam x, which will be for all sprites, and then cam y, which will be for all sprites again. And then we have, okay, so then after that we have set x to, since we're looking at the sun, we're going to set the x and y to 0, because the sun will be at the center of our plane of reference. And then we will go to, oh, and one more thing, we should do zoom, like this, set, and yeah, and then in the backdrop sprite, oh wait, first let's actually set this. So we need these two functions, and then these ones will be divided by zoom and zoom x and y minus cam x and then minus cam y. There we go. And just like that, it sets the position of the sun. We could even set that we could even set the sprite of the sun. And then for the size, we can set it to, we could even set up a private variable called size. This, and then we have this. So the size will be of the sun, let's say it'll be 100, because that'll be the diameter pretty much. And then because the sun is 100 times the diameter of the sun is 100 times the diameter of the Earth, so its volume is 1,000,000 times the Earth's volume. We'll just use Earth as an example. So let's set it to let's set the size percent to size over zoom. As you can see right here, it is filling the entire screen, and that is something that'll be fixed very soon. But anyway, now we have the sun. Let's add a background sprite, a backdrop sprite. Oh, and then one more thing, we should set the sphere of influence. Actually, yeah, for the sun I don't need that just yet. Let's hide all of these variables to clear up this space. And then go back to the backdrop, and we will set up forever, then we'll set zoom to 1, and then set cam x to 0 and cam y to 0, like this. And then for our zoom in and zoom out, we can use the up arrow and the down arrow. Actually, we could use let's see, we could use E and Q. So Q is right here, and then E is going to be right here. And then for the zoom, we will not be using zoom, except for the Q we'll be using set, whereas for E we'll be using change, zoom, and then zoom. Change zoom by zoom, this multiplies it. And then set zoom to zoom divided by 2, like this. So now we can zoom in and zoom out. And then now we pretty much have Q and E. Then we will be using the if and then blocks. That way we can have the arrow key, we'll have the WASD, W, A, oh, sorry, S, and D. Like this. So now we have the 4 letter characters, and for W we'll be changing the cam Y by 1, for A cam X by -1, for D by 1, and for S Y by -1. So now it moved a little bit. We could even, and we could actually speed this up. I think we could use zoom. Like this, and then plug you in. There it goes. Now if we zoom out, we can move a little bit faster. And we can sort of move it around the sun. Okay. And we could even name it to star like this. So now we have all these different controls, and we're able to move the sun around. So the next thing we need to do is we'll duplicate the star, and let's name this, let's give it a name. Let's name it some plan, maybe Tron, I guess let's call it Tron. And then in Tron we'll be using 2 different variables, which will be the semi-major axis and the semi-minor axis. So we'll doing semi-major axis. Like this. Or we can have it all lowercase. Semi-major axis, and Scratch supports spaces. And then the semi-minor axis, like this. And then we'll be adding a variable called eccentricity, which is the different stuff, which is pretty much the ratio. The eccentricity is set by this. Eccentricity is equal to the square root. Okay, square root of 1 minus semi-major axis times semi-major axis over semi-minor axis times, or semi-minor axis over semi-minor axis times semi-major axis squared, like this. When we have, now we have this little equation for calculating the eccentricity. Next thing we'll need to do is actually set the semi-major axis, and then the semi-minor axis to 1. And then, and then we'll also add sphere of influence. For the sprite only. And this is pretty much, and then the sphere of influence will be setting, so let's say, okay, let's put something here, and let's say begin values. We could remove those since we won't be needing those right now. So okay, we can remove it then. So all of these beginning values are our orbital parameters. We'll even be using for this sprite. Let's also use for this. Let's also use I guess argument of argument of periapsis for all sprites, or actually for this sprite only. So that way we could also set it to 0. This pretty much just rotates the whole thing. It's an orbital parameter that's adjacent to inclination and argument in the longitude of ascending node, which are not supported on 2D. They're not a part of 2D orbital mechanics, which we are going to do. But these just rotate the whole thing again in different directions. Anyway, so we have now all these. Let's set this to star. And then let's see, space, fantasy, dance, porn, music, sports, food, fashion, letters. Let's see, Earth. There we go. And I don't know. Let's see. We could have. I don't know, we could probably have this. We could do this just to make it look like a different, like a super Earth. And then, let's see. Let's also include the orbital period for the sprite only. Let's set so now our eccentricity is set. Let's set our orbital period. And the equation for this is the square root of the semi-major axis cubed. and that cubed over the semi-major axis's mass. Oh yes, and then we should also set let's set the mass to 100 or 1 million, since Tron is pretty small. So mass 1. Set the orbital period to, let's see, we can also double check here. Orbital period. Orbital period, there we go. And then, here it is. And then we've got, okay, A, yep, this is the equation. We could actually ignore the 2 pi, for now. We could actually ignore the 2 pi, so we don't have to do that. And then, let's include semi-major axis. And then our gravitational constant will be doing it as star. And then we'll be doing mass of sphere of influence. And the mass of our sphere of influence is 1 million, whereas this one is 1. So now we have our orbital period. And then the next thing we'll need to do, we'll increase input a variable called time. And because it's backdrop, it'll be public. Change time by 1. So when you start, set time to 0. So now, and then the other thing we'll need to do is, let's see, just write only mean anomaly. And the mean anomaly we'll set to, let's see, we'll set the mean anomaly to the backdrop time. We could even include let's see, well, we can even include initial mean anomaly, which we'll set to 0. And besides, everything in this will be just radians. And then time divided by orbital period. Like this. Now we have our mean anomaly. And then for our eccentric anomaly, we'll be using that for the Kepler's equation, which is, let's see, let's go back, which is described here. This is the equation, but to solve backwards, you can't really do it exactly. You'll just need to do iterations. So for that, we will use a multi-block that runs without screen refresh. And let's say calc eccentric anomaly. We'll add an input number, which is iterations, like this. And then we have, okay, then it'll be repeating 100 times, or rather iteration times, calc eccentric anomaly. So first, So, and this one is a special one. So the first thing we need to do is we need to set the eccentric anomaly to the initial mean anomaly, and then after that we'll be setting the eccentric anomaly to the mean anomaly plus the eccentric anomaly plus the eccentricity times eccentricity times yeah, that's good. Eccentricity feels like something's wrong here. Should be good. Oh wait, the eccentricity is actually set to 1. It'll do it by itself. So we'll set it to the eccentricity times the sine of the eccentric anomaly. And this will repeat this over and over. And the more iterations, so if we do 100 iterations, I think 100 is about enough to make this. If you're into space, probably a 10,000 or a million, because you want to be really accurate. Oh. Sorry, the garbage apple chargers just pops right out if you hit it even just slightly. So now we have this is multiplied by the sine of the eccentric anomaly. And let's see, what else do we need? I think this is good. So now we have calculated the eccentric anomaly. And then after that, we will set the x. And then we'll also set the y. Like this. And we will set it to... Oh wait, one more thing. We need to... two more things. One, will need to do the initial initial mean anomaly. Like this. And then the other thing we'll need to do is convert this from radians to degrees, because Scratch uses these sine and cosine equations and arcsine equations. They use degrees, and we are going to be using radians, so we need to convert this from radians to degrees. To do that, we divide this by 3.1416, like this. We insert the eccentric anomaly like this, and then now we have the sine of the proper value. Because if we don't use radians, we will be having all sorts of issues coming up. So that's why we'll need to use this. And anyway, so now we will be using, for our x, we will be using that. And it'll be the semi-major axis times the cosine of the eccentric anomaly minus the eccentricity. So let's take the semi-major axis like this times this little value, which is sine, or the cosine of the eccentric anomaly minus eccentricity and then we'll set the y to the semi-minor axis times the sine of the eccentric anomaly, because the circle there we go. So then we'll take this out, because that'll shift it way out of focus. So now this is the equation. So now we have this. Except that we'll need to change the semi-major and semi-minor axes so that that Tron orbits. And then we could also, the other thing we'll need to do, maybe let's create x1 and x and y1 for this. And then we'll set the final x and y to the rotation equation. X and y. And then here we will be using x1 and y1. Or y1 this. And then x and y will pretty much be the rotation equation. Not a lot of people know the rotation equation. Oh, and then I almost forgot, one more thing we need to do is have the converted values here. I almost forgot, sorry. Because we need to use radians or else this thing will be screwed up. So now it's good. The next thing we need to do, I mean this part you can keep in degrees, but for the sake of it, I'm just going to use radians. So let's use plus and plus. Then we'll also need times and times this. And then why is it randomly doing that? Then we'll use cosine, cosine, and then sine and sine. And there we go. And the other thing we'll need to do is make this a minus, because the rotation that's how the rotation equation works, to sort of have a point be rotated around its origin. So we'll need to use, okay, and then the next thing we'll need to do is argument, 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 and argument. Then we'll plug each of these in. And if you don't want to include the argument of periapsis, you don't have to. You can just set these x and y values as they were before. But yeah, just to show you, I'm going to be doing that. We're using x, set x to x1, and then y1, and then y1, and then x1, like this. And over here, as you can see, Tron is over there, but he's moving pretty slowly. So let's create another variable called time warp. And as the game starts, let's set time warp to 100. So time warp, we can have a slider. To make it a slider, we double click this, and then we change slider range. Let's say the maximum value is, let's see, minimum value, maximum value, like that. We have, so time warp, let's set it to, by default, let's set it to 10. And then for time, we will be changing it by 10 to the power of time warp. And then the next thing we can do, we should also just hide these. And then let's bring back in the time warp. See, it's time. Yeah, so it looks like time is actually increasing now. Let's see. Is it right? Is Tron moving? Nope. Oh wait, yeah, that's actually. Alright, so now I'll be doing some troubleshooting, guys. Alright, let's see. Make sure this is, yeah, that's right. So, oh, and then maybe, okay, my mouse is really glitching out. So, eccentric anomaly. Let's make sure the eccentric anomaly. Oh wait, I know why. It's because it's this. Okay, sorry guys, I messed up a bit. Um, mean anomaly. Mean anomaly. So now we're going really fast. So to do that, to slow us down, we can use minus 100 maybe. Or minus 10 maybe. And or we could even use the natural number. I think the natural number might actually be better. So let's use 10. So 10 really slows us down. Like this, and then, yeah. We could even divide time warp by... Let's actually divide time warp by 10, and then minus... I have that minus 1. Just 2. 3, 4... And you can set these to any value you want, pretty much. Let's see, how about... Let's see... So... I think 10 might actually be a little too much, so let's do it by 4. And now we have an orbiting Tron. So now we could increase the semi-major axis to 100. Maybe even 1000, and then set the semi-major minor axis to 900. Now if we reset like this, here's Tron, and let's increase the time warp now. So Tron orbits pretty far away, but as you can see, it speeds up and slows down. It speeds up as it gets closer to the star it's orbiting around. So yeah, looks like we now have an orbiting planet, guys. Now, if you want to add any more celestial bodies, for example, maybe let's make a moon of Tron. We'll set the size to 0.1 or maybe 0.3. Let's name it. Let's name it. Maybe Stone Cold. And then we'll fill this like that. Oh, and I also forgot one more thing. We'll need to add the sphere of influence's position. Like this, sphere of influence. Let's see, star. And then will be the X. And then the Y. Yeah, and then let's make sure that it is the sphere of influence. That, and then add that, and now it'll sort of be centered around its sphere of influence. We'll need to duplicate that step for Stone Cold, which is going to be its moon. We actually add this right here. How about let's just do this, X and Y, make sure that we have that it is inside of our sphere of influence. That, and then we have, so now we can set, now Stone Cold, we can set its sphere of influence to Tron. And its mass, oh, we could even reduce its mass here as well. Semi-major axis, let's say 5, and then 4.5. So let's go to Tron. And as we can see, it's actually kind of inside of Tron. So we'll need to solve that. Alright, let's see. Maybe let's increase this. Like I said, it's 45. Oh, and now Stone Cold is outside of Tron. So now we have the two objects orbiting each other. We could even lower it. Let's see, by 10 and 9 I think would be okay. So let's go to the system right here. And now, as you can see, Stone Cold is sort of slowly orbiting around Tron. So let's go here. I think this part I screwed up actually. Might have been that I flip-flopped them. You're supposed to get the semi-minor axis cannot be larger than the semi-major one. Alright. Yep, Stone Cold is slowly orbiting Tron. We could even increase the mass of Tron. So let's increase its mass to 10. Stone Cold, we can set it to 0.1. And now let's go back to the system. Yep, and as you can see, Stone Cold is significantly moving. A little more significantly. I really can do it, set it to 350. Let's see, massive Tron. Okay, now it's orbiting faster. Yep, here we go. So now you can, as you can see, Stone Cold is moving a little bit faster. We could even do it in 2 and 1.8. And now we have a system. So yeah, if you want this to orbit faster, you can just play with the values. Alright. So the mass of this is 350, whereas this one is 1 million. We could probably set this to 2,000. I think this might make a little bit more sense. Alright, let's see. Yep, there we go. So now it's starting to move faster. And that is because in each sphere of influence, we're taking the mass of the sphere of influence into account. So that way, the sphere of influence is, so that way it sort of orbits based on how heavy this thing is. That's pretty much how the orbital mechanics work. And let's say I want to add another planet. I can call this Kyle. Its sphere of influence will be the star. And we could even play with its argument of periapsis. We can set it to 1.07 radians, or maybe 57 radians. Its initial mean anomaly, let's say 5. Its semi-minor axis will be 30. And then let's test it out. Let's see. Oh, and then the other thing we can do is make this smaller. That we can have and then we could even have craters. And we could set it to be bigger than Tron. What size? Let's say 2. So now we have another planet in this system. And how about we increase the semi-minor axis? So as you can see, its orbital pattern has changed. However, it's still intersecting the sun. Maybe let's change it to 250. Alright, speeding up towards the sun. And there we go. Here goes Kyle. It goes on a very close approach to the sun. And so yeah, you can just sort of watch this all day if you wanted to do so. Go. And yeah, so, and we could even make it make a bit more sense if we have it at 500 f the semi-minor axis at 500. And so now we can see that as you can see here, Kyle is orbiting around Sun, just like Tron and its moon Stone Cold. So anyway guys, I hope you found this tutorial useful. If you liked it, leave a like, comment down below, subscribe, and I'll see you guys in the next video. And I could even do this. Bye bye.